Hello everyone. We are Team 8 members Subin Kim, Shinung An, Hee-kyung An, and Songbom Ho. From now on, we will proceed with the SRS presentation. In 2020, over 15.7% of the population were over 65 in the Republic of Korea and predicted to be over 20% of the population in 2025. As it is, elder people tend to be more fragile and helpless, and they are in need of constant monitoring. In fact, there are some remote medical apps that provide several functions that allow the linked hospital to handle all the processes from appointment to information, payment for medical expenses, and claims for lost insurance without face-to-face with the teller, such as Lemon Healthcare or Good Doc. However, we wanted to focus not just on interactive communication between patients and hospitals, but also on caring for vulnerable people such as elderly people living alone by adding a role of caregivers. So, we propose an emergency healthcare platform where it can serve as a communication platform between the elderly and their caregivers or hospitals. It also records medical issues and prescriptions which can be shared in emergent situations more efficiently. This may serve an essential role during the golden hour where the patient's life and death matters in seconds. Our app will link with real-time behavioral analysis sensors using FMCW radar rather than simply aiming for interactive communication between hospitals and patients on the platform. Caregivers can remotely identify the status of elderly people living alone. Therefore, we always prioritize convenience, speed, and structure when designing apps. To implement our objectives, we wanted to simplify the process of identifying the status of elderly people living alone so that we could easily check the status anytime, anywhere, and focus on emergency situations instead of caregivers who would be confused in case of an emergency. Our app has two large product features. First one is real-time monitoring system for old person behavior. To be specific, the behavior of the old person is analyzed using FMCW radar and presented in three states: safety, absence, and risk. Next, emergency situation notification system. It's sent to the linked caregiver's cell phone, and a paramedic is called when an elderly person living alone becomes at risk. And our operating environment should be database of information of patients, such as SQL Plus database, and also available on mobile device, especially an Android platform with API level no less than 14. And last, real-time status analyzed using FMCW radar. The following assumptions are required to facilitate the use of this platform. There is a need for the well performance of Android phone since our app is based on Android. Second, it is assumed that users will possess decent internet connectivity. Third, app should operate normally on both the caregiver and the patients. Fourth, FMCW radar should be connected to the network. Last, it is assumed that the user's mobile phone is allowed pop-up notifications.
This part is about system description. The first user case is account login and registration. The main actor is user, which asks for account registration or login to the user DB, which is secondary actor. When a user asks for login, ID password should be matched with previously registered members. When user is not registered, he or she should ask for registration. Also, the system would validate the user identity with the information given, such as birth date and social security number. This is the following sequence of registration use case. Related requirements are social security number, email, phone number, birth date, address, preferred hospital. First, user asks for registration with related requirements. Then, the platform validates the user through authentication interface. If the validation succeeds, the platform will register the ID password in UserDB. The user will then choose the type of user, which is between patient and caregiver. This is the following sequence of login use case. When user asks for login, the user will type in ID and password. The UserDB finds the matching ID password and returns the result to the platform. The platform returns the result to the user. If validation fails, the user can get a temporary password from the system by sending email and ID to the platform. The platform makes a new password and sends the password back to the user by email. And this is the case of users match. The main actor is patient and caregiver, and secondary actor is UserDB. In this case, the caregiver correctly finds the patient he or she will support and gets access to the DB, and the patient correctly finds a caregiver to care for him and her, gives access to the DB. This is the sequence description for users matches. The related requirements are user to be registered beforehand, and the matching system should be implemented in the platform. Firstly, caregiver can find the patient by birth date and name, and system sends acceptance request to the patient, and then the patient can reject or accept, and only if the caregiver is accepted, he or she can get the access of the patient information DB. Next use case is added medical information. Main actors are patient and caregiver. Secondary actor is medical information database. If user clicks edit button in app and writes new medical information and then clicks save button, then editing is done. But if there is no change or exists omission in new information, it falls to store. So secondary actor, medical information database, gives existing medical information at the first time and receives the new medical information such as blood type, disease list, and store at the last time. This is a sequence diagram of added medical information use case. To start, checking medical information should be preceded. If user requires medical information to platform, then the platform fetches existing medical information from database using ID, and then return the medical information. After checking the medical information, the user asks for edit to platform. Then platform gives existing medical information and allow user to edit. User write new medical information and click save button. The medical information database stores new medical information and editing is successfully done. However, at the end of the main flow 3, if there exists omission or there's no change with the existing information, then edit is failed. Return to beginning of main flow 3. Next user case is emergency situation. Main actor is caregiver and secondary actor is medical information database, connect hospital system, FMCW reader, and platform. In this case, the system sends the emergency alarm and information of a matched hospital and rescue monitoring progress to the caregiver. And this is the sequence diagram for emergency situation. To start, FMCW reader and the mobile device should be connected and can define the movement status. And FMCW reader found the emergency situation and the platform caught it correctly. Firstly, system send the emergency alarm to the caregiver and find the nearest hospital and call for rescue. And then send the information of the matched hospital to the caregiver and the patient's information to the matched hospital. Finally, monitoring the rescue progress and notice to the caregiver.
Hello, I'm Hee-Kyung-an. I'm going to present next use case. Next use case is added medical information. Main actors are patient and caregiver. Secondary actor is medical information database. If user clicks Edit button in our app and writes new medical information and then clicks Save button, then editing is done. But if there is no change or exists omission in new information, it fails to store. So secondary actor medical information database gives existing medical information at the first time and receives new medical information such as blood type, disease list, and medical information database store at the last time. This is sequence diagram of edit medical information use case. To start, checking medical information should be preceded. If user requests medical information to platform, then the platform fetches existing medical information from database using ID, and then return the medical information to user. After checking the medical information, the user asks for edit to platform. Then platform gives existing medical information and allow user to edit. User writes new medical information and click Save button. Then medical information database stores new medical information. Then editing is successfully done. However, at the end of main flow 3, if there exists omission or there is no change with the existing information, then edit is failed. Return to beginning of main flow 3. Next use case is real-time monitoring. Main actors are also patient and caregiver. Secondary actors are FMCW radar, which detects a movement, and monitoring database. If click real-time monitoring button in our app, user can check patient real-time state, either safe, emergency, or absence. In this process, the FMCW radar transmits movement data, and our system processes it and classify it into 3 states. And then monitoring database receives that classified state and store it. For real-time monitoring, we need information processing and state classification function implementation. First, user asks real-time monitoring state to platform. Then platform gets movement data from FMCW radar and processes and classifies into 3 states: safe, emergency, absence. After to finish classifying, store the result on monitoring database. Also, return the result state to user. Now, I'm gonna talk about preliminary user manual. Our platform's target users are 2 types. Elderly people living alone with chronic disease are type 1 users, and caregivers of type 1 users are type 2 users. They should have smartphone to install our application. For these 2 types target users, we decided design direction of UI like this. First, we will use a large font size than other common applications for the elderly patient. Also, all words in our app, including the name of our app, will be in Korean for the elderly patient. To make it easier to recognize, we will use not only text, but also intuitive icons. Last, the buttons of frequently used functions will be largely arranged on the main page to improve convenience. So, this is expected graphical user interface.
The non-functional requirements should suit both the patients and the caregivers. Specifically, this system should have good readability so that it could be easily used by elderly people. The scope of this system is restricted to applications in mobile device. 2 types of users that need documentation is expected: the general users such as elderly and their guardians, and administrators who manage the system. For general users, documents should describe how to use formally mentioned user cases. It should also include installing FMCW radar. For administrators, it should include overall description of the lower-level code and interfaces. System should be available on mobile devices at Android platform with API level no less than 14. Device is proposed to have at least 40 MB of free space. System should respond within 2 seconds. The system must notify the caregiver within 5 seconds in case of an emergency. System is proposed to use internet connection at speed about 250 kilobyte per second. System may have delay when working at low internet connection, but it should still work properly. It should notify the user if internet connection is lost. Also, it should notify failure happens when getting information such as personal information, checklist records, radar data. Input comes only from users directly and no other system are used for input. Our system includes FMCW radar. App is expected to have 100% reliability, working 24/7. The downtime of a system should be 0. In case of failure, the app should restart within 5 to 10 seconds. The UI is the most likely to be modified. The application is expected to be hosted at Google Play servers. It is necessary to have additional FMCW radar sensors that can be interlocked with application. Sensors must be installed in a fixed place where the elderly are usually living alone. System administrator should have access to any data so that he or she can control and modify any unacceptable information. The DB shall have a security system so that information cannot be accessed from outside, and the information shall only be available if necessary. The system is expected to be backed up once a week and checked out regularly. The application will be designed through the Android Studio application by 4 members of our team. Raspberry Pi 4 is used to relate FMCW radar sensors with application. Developers need to know the object-oriented programming, and first version should come out before November and beta test to users. The project will be completed no later than August next year. All 4 developers are responsible for system registration and system AC services. This was the presentation of team8. Thank you for listening.